Hello everyone and welcome back to another project. In this project I'm going to show you on how you can control your electrical appliances by using virtual reality, more specifically by using virtual buttons. So it's a mixed project that incorporates both computer vision and automation, and I had to write two codes. One is for the computer vision part and the other is for controlling these hardwares on the ESP32 board. So for the computer vision based part, I have written a code on Python that I'll be running on my laptop, but later on I'll be deploying the entire project on Raspberry Pi and I'll be showing that in one of the later videos. So as usual, initially I'll be talking about the features of my project, then I will show the components that I've used here, and finally I will be diving into the demonstration, the way the project works. So let's talk about the features. So it's very simple and straightforward. As I run the code on Python, a window will pop out that will be taking the video feed using my webcam, and on the screen you'll see shortly that there will be two buttons like this. As you click on the first button, then the first bulb, that is the red bulb, will turn on, and as you click on the second button, the yellow bulb will turn on. So that's all about the very basic feature of my project. And then I would like to talk about the components that I've used here. So as you can see, as the microcontroller, I have used the ESP32 board. There are a number of reasons for using the ESP32 board. First of all, it's very cheap. Second of all, it's very small as compared to the other boards, as compared to the other Arduino boards. And most importantly, it comes with a built-in Wi-Fi that will eventually allow me to connect with the internet to generate local servers. Now, as I've told you that I had to run the computer vision based part on my laptop, and I'll be controlling the hardware using the ESP32 board. So there must be communication between the laptop and the ESP32 board, and there are multiple approaches that we can follow to ensure the communication between the ESP32 board and the laptop. For example, we can do so by using serial communication, but in that case there must be wired connection between the ESP32 board and the laptop, which is not feasible in some of the cases. That's why we have alternate options. For example, by generating a local server on the ESP32 board following HTTP. But in that case, as the request is over and over again posted and closed, it takes a while. I mean, the commands to send from the that are to be sent from the Python, it takes a while because it has to open and close the server over and over again. So there is a significant lag in that case, and the screen freezes in most of the cases, resulting in significant decrease of the frame per second or the FPS count. So that's why we have alternate option, which is the WebSocket. So in the WebSocket, what happens here is that the ESP32 board generates a local server, and data is exchanged between the ESP32 board and the laptop by using the WebSockets. That doesn't essentially over and over again open and closes the connection. That is the best part. That is the best part. It almost gives us the speed of communication which is almost equal to the serial communication, and you don't require any kind of wires, which really makes it very much indeed feasible. So these are the major reasons that I've used the ESP32 board. It's smaller, it's cheaper, and it comes with a built-in Wi-Fi. As you can see that I have these bulbs over here. Let me change the color. Yes, I believe you can see this is the red bulb. This is my first bulb, bulb 1. And over here you can see that I have another bulb, which is the yellow one. I believe you can see that quite clearly. The second bulb, the yellow one. So these are the two bulbs. These are two AC bulbs, and the control signals that will be generated by the ESP32 board are DC. So it is not possible to switch this high voltage AC signal using the very small DC signal generated by the ESP32 board. That's why I have used a 2-channel 5-volt relay module. I believe you can see it over here. I have used a 2-channel 5-volt relay module, which is used in order to switch the high voltage AC loads using the low voltage DC control signal generated by the ESP32 board. And to power the relay module and the ESP32 board, as you can see that I have used here a pair of lithium ion batteries. These are 3.7 volt lithium ion batteries, and in together in series they will be generating around 8 volts. However, the ESP32 board has to be powered with 5 volts, and the relay module is also 5 volt tolerant. So I have to step down the voltage which I have generated. I mean 8 volt has to be stepped down to 5 volt, and in order to serve that purpose I have used As you can see, I have used the let me change the color. I have used the LM7805 linear voltage regulator. So no matter what you give input above 5 volts, it will be giving you output, constant output of 5 volts. And using these 5 volts, I have powered up my ESP32 board and the 2-channel 5 volt relay module. So that's all about the components that I've used here. So right now, with no delay, I would like to dive into the demonstration part. So right now, I would like to show the demonstration. So I'm running the code and I've plugged in all of my devices, and the screen should be popping out very shortly. That will be getting my video feed, and yes, you can see the screen. You can see that I have two buttons on the top of the screen, B1 and B2, which are entitled as virtual buttons, and as I click on these buttons, the bulbs will be turning on. So let me show you if it's working perfectly. You see, as I've clicked on the first button, the first bulb has gone on. As I've clicked on the second button, the second bulb has also gone on. So as you can see, I've also overlaid a graphics on top of the left and the right corner that corresponds to the first and the second bulbs respectively. And now if you want to, by simply pressing on these buttons once again, you can turn off the bulbs. So let's see if the turning off is working perfectly. And the graphics that I've overlaid, they will also go off as soon as I turn the bulbs on. I mean, as I toggle the state of these switches, the state of the bulb will also toggle. So let's see if it works. You see that the first bulb has gone off, and I'll be doing the same for the second bulb. You see that the second bulb has also gone on. Now you can do the same with your left hand. For example, B2 is closer from my left hand, so I'm trying to turn it on using my left hand. You see that the second bulb has gone on. Now if you want to, you can turn on the first bulb once again. Turned on, turn them off, off, and off. So turn on B1, turned on, turn off B1, turn off, and turn on B2, turned on, and turn off B2. You see it's been turned off. So both of them are turned on now, and let me turn them off. You see the color has also changed to green once they are turned on, and when they are turned off, as you can see, they are returning to their base colors. One is the red one, and the other is the some kind of like greenish color. And once you press the buttons virtually, you can see that the color of these buttons become yellow. It means that you have kept in contact, you are in contact with the button, and you have not release your contact from the button. I mean, the contact is not physical, of course it's a virtual contact. So as I remove the index finger, the tip of the index finger, you will see that the yellow circle will turn into green, implying that the bulb has been turned on. You see. So I believe I have been able to clarify myself quite enough. You see B2 is on. Now let me turn them off, off, off. So it's working perfectly. I believe I have been able to clarify myself. So that's all for now. Thanks for watching. Stay tuned for the next one. Bye for now.